Alright, can y'all hear me? Y'all hear me? Alright guys, anyways, we are live. Let me know how it is. See the audio is. Can y'all hear me? Alright, again, it's the usual, okay, should be fine. Y'all hear me? And, yeah, there's no Rumble, I was trying, Rumble, you can't schedule. I have one scheduled for Saturday, but then I can't go live today if I'm scheduled Saturday, so it's really weird. I emailed them, they're like, they don't know what the world's going on. I'll just show you quickly. So I said, hi, Rumble, I'm trying to live stream today, but Rumble won't let me because I have scheduled another live stream for Saturday. The prompt told me to contact this email, and they just said, it's in the FAQ, read this account verification. I'm like, that's about account verification. Like, what are you talking about? Anyways, yeah, for those, let's see, we'll just start going in here. How many people are on the thing? We have 0 people in. Okay, guys, anyways, we're taking over the game. 0 people, it's all good. Again, this is, remember, these morning streams are literally to force myself to focus on for energy tech or just science and so on, because okay, I'm supposed to be live though. Why is it not live on this one? But it literally says I'm live. Okay. Okay, now it's okay. It's still not like whatever. Anyways, I'll close this. I'll check the audio on this. 0 people in. Okay, guys. Okay, anyways, I'll close this. Okay, so and here's the threadcast. For those people eventually that do show up, if they do, it's all good. Okay, threadcast will be in here and so on. And well, yeah, since nobody's here, I'm just gonna go straight into the thingy. Pete Dinu. All right, oh, audio's good. Okay, Rody metrics in the show, epic stuff. All right, yeah, and yeah, this Saturday's stream is gonna be pretty epic. And also note that yeah, I'm gonna try to do the Saturday streams every other week. It just gives me a lot more time to prepare. I don't like feeling rushed doing the live streams anymore. And yeah, so now I could actually focus on it, and I'll start publishing the trailers like instead of unlisted. So then and then it also gives like a full week for people to put their thoughts and so on. So yeah, so like you sent me the message, Roy Matrix, about the thing under the alleged plane. And so on, yeah, so it gives me more time to look at it closely and so on, as opposed to doing it all in like instant live. And yeah, so it's pretty good. And yeah, so this Saturday's gonna be pretty epic. Gonna go over the UFOs at 9/11. All right, and let's see where I left off here. Okay, anyways, I'm gonna go back here. I'm gonna go over spherical harmonics quickly. Yeah, sounds good, MS. Yeah, sounds good. Yeah, so yes, basically, I'll try to do every other week. It's just much. It just saves me a lot of like headache. Namaste, Sorke, Sharike, epic stuff there. We got the penguins in here. Epic stuff there. Yeah, so speaking of penguins. Penguin is the... So apparently this penguin is inspiration for this guy's hair. This guy's a disinfo agent slash his brother apparently died in 9/11. So that's quite ridiculous. So this guy's hair, and then this other guy commented. This guy, he found a fan of Campbell in Germany. So this guy's in Germany, he's got his hair like that too. Okay, this is pretty wild. Is this a German thing, or what's going on here, guys? It's like Germans do the Germans always have next level hairstylist? Like you got the short mustache guy, the the Hitler guy. You got now this guy. All right, namaste, guys. Okay, I'm gonna go over. So we'll see where I left off last time. Okay, we haven't got to the sound waves yet. Okay. But yeah, we haven't got to this. This is why, again, I'm pretty sure this guy's on the ball. And also, Ionel Dinu actually emailed me saying that he was looking at my like he noticed that I was talking about it. The Dinu, Ionel Dinu. So he actually messaged me saying, "Hi, Matthew. I noticed that you were discussing my paper online with your friends. Thanks again for your interest in my work. References II-16 and II-18 at page 12 /45 of my paper are hard to find on the website because the videos are embedded in their story. Here are the direct links to the videos from where I took the captions. I've also used a screen recorder to record all the videos because they cannot be downloaded. Yeah, so here and this one here, spherical harmonics and so on. Okay, we discussed the Bohr model, which leads to a new interpretation of the Balmer formula, and so on. Yeah, this is about the spherical stuff. Yeah, I definitely want to. I'll be doing a video on spherical harmonics. It is. Just from looking at it, it's pretty important to grasp what a world we're talking about, how we can use just everything, quantum mechanics, electromagnetism, radio waves, how they can all be described just by vibrations. Linux is inspired by Penguin, and I inspired, and you're inspired by Linux. Interesting. So Penguins are the setups. Okay, so let's go back here. I don't see where we left off. Okay, we left off here. Okay, this is part where we essentially left off. And then I think we mentioned spherical harmonic. Yeah, this part here. Okay, I'm going to go over some spherical harmonics quickly, just to recap on spherical harmonics, and then we're going to keep going on. So this is, the vibration here. So when you vibrate, you'll have this shape. This is based on the highest probability. This is like an orbital, highest probability of an electron and so on. And that could be described as resonant of vibrating sphere. And we'll go over that this part here. Where's the other one? This is this one. Okay, this is this video, spherical harmonics, and here, and this is the video there. But you could also see it on YouTube. I just don't like how they don't. There's no like make it full browser width, not the full screen, because I have a massive computer and there's not a chance in the world I'm gonna be making a big screen. Yeah, so I'm gonna go over here. So I sent them. Yeah, this is their channel. The Bohr model. We'll go over the Bohr model quickly. Okay,
in 1930,
this one is I2. The Bohr model. Okay, we're gonna go over Bohr model on this one, and then yeah, we'll go over that later. There's a whole bunch of spherical harmonic stuff. I definitely want to go over the math and then make a video separately on this and the orbitals. All right, so that's this one, and then the spherical vibration harmonics. This is the video, and then I believe the next one is spherical harmonics. I'm gonna go over here. I'm gonna watch these again. I think that one we already saw, but just a recap, and then we'll go over it. And unless you guys have any other questions, send those links in the live chat, sir. Okay, spherical. Okay, this is the one. This is the second one. Okay, okay, this is the this is YouTube. Okay, this is this one. The links, that's this one here. You can see these links in the live chat. Yeah, you can see this link there. I'll put it there. And yeah, and then the other part is I'm gonna go over here. I'll put it also here. And also put it on the threadcast. So again, any links I sent, I'll be everywhere here. Okay, and threadcast. And this is the other one. This is their the website, but you can also search on their YouTube and so on. And yeah, okay. And then this is here, and then lastly, these are the 3 videos. I'll send this one. We'll watch this first one, and then yeah, we'll watch this first one. I'll send the link to everywhere, and we'll watch the first one on YouTube, which is easier. Because yeah, people have to realize, like, this is why people use YouTube. They understand it's just simplified. I'll also summarize this, so it's on the blockchain. Yeah. This is kind of what I mean. It's like if you want to compete with YouTube or get people watching your stuff on YouTube, you have to be better or at least as good. All right, like a horizontal. This one here, look, I can go watch it fill up the entire browser as opposed to the full screen of the computer. Anyways, let's play this. This is okay. All videos are from here. Quantum vision is gonna be found here. From Bohr's atomic model to matter waves.
13. Niels Bohr. In 1913. Niels Bohr proposed his famous atomic model. According to this model, electrons can assume only certain orbits around the nucleus. But first things first. Bohr put together the knowledge blocks available to him at that time and created a kind of a recipe book. We know from the Rutherford scattering experiment with a gold foil that the atomic nucleus is tiny relative to the electron shell. But how are the electrons moving around the nucleus? A possible, albeit naive, explanation would be compared.
I'm gonna just start lowering my thing. I'll go back to that part again. Lowering my desk. Get on this. This is gonna be epic stuff. And again, the whole idea of this model of Aether, I think that's that's pretty much where you connect quantum and macro mechanics. Planetary model of atom is pure Kabbalah, as above, so below nonsense. Interesting. Yeah, but again, this is just the pre stuff. Let's go back here. Let's go back here.
But first things first. Bohr put together the knowledge blocks available to him at that time and created a kind of a recipe book. We know from the Rutherford scattering experiment with a gold foil that the atomic nucleus is tiny relative to the electron shell. But how are the electrons moving around the nucleus? A possible, albeit naive, explanation would be comparing an atom to a planetary system. The nucleus would correspond to a sun, and the electron to a planet, which is held in a circular orbit by electrical attraction. The problem with that theory is that an accelerated charge would have to radiate energy like an antenna. The electron would lose energy and eventually spiral into the nucleus. Such an atom would be unstable from the classical point of view.
Also, note again, an accelerating electron sends a photon. In other words, it's literally, if you accelerate, you're pushing all the ether, and that you're getting a vibration across the ether. So you're not just creating photons out of nowhere. So that's kind of another part about the particle physics. It's like if you reify them as if they're real things, you literally have to be okay with they just pop into existence out of nowhere.
Bohr postulated that atoms were stable, but could not explain why. He assumed that electrons could follow only certain discrete orbits, but it follows that only certain discrete electromagnetic radiative transitions are allowed. Transitions are radiationless when the electron jumps one orbit closer to the nucleus. When the electron stays in the smallest orbit, the so-called basic state is reached. According to Bohr, the permissible
Greener's recent live covered Aether connecting quantum mechanics. Quoting a guy called Chuck Bennett who has a fascinating Aether Q model. Interesting. Yeah, I was gonna actually show the quote from Martin Fleischmann that Bob Greener shared. He says basically whoever comes up with the Aether model connecting, or not Aether, whoever connects quantum to other one gets the cold fusion. One idea is the speed of light is a limitation caused by pressure from the ether, which can be circumnavigated if you have a mechanism that can split apart the ether as it moves. Interesting. Yeah, that's pretty much the speed of light barrier is just the rate of induction, or just rate of the propagation of a wave in the ether. It's kind of like what's the sound? Yeah, it's kind of like the sound. What's the speed of sound? Or and depending on the medium, you can have a different sound medium. But this is of the ether, and then this one you can go faster. Yeah, but yeah, you can do you can circumnavigate it. But again, you may be or may not be. But the idea is, if you understand, if the model's correct, you can actually start doing things like without just without the usual guesswork of quantum mechanics. Let's play here.
Permissible orbits are characterized by the angular momentum. The angular momentum must be a multiple of Planck constant h bar.
Okay. So now he's adding angular momentum based on the speed and the basically the speed slash mass of it. And they're saying it's quantized, so each orbit has a different one.
What about the energy of the electron? Generally speaking, a bound state is characterized by negative energy. The electron receives positive energy and can leave the atom only when this so-called binding energy is overcome. The atom then becomes ionized. However, we are talking about bound states. In particular, the basic state and the smallest orbit with n equals 1. The next higher orbit, n equals 2, has more energy. The orbit, n equals 3, has even more energy, and so on. When talking about transitions in which electromagnetic radiation is released, let us recall the Balmer equation as generalized by Rydberg. We are now able...
Alright, this is the waves. Okay, this is wave. I think this is frequency emitted based on the energy level it's at.
We are now able to interpret the difference between the numbers n and m as the difference in energies. For example, between shell number 2 and shell number 3. As we can see, Bohr proposed an ingenious interpretation of Rydberg's findings. Bohr's postulate of discrete orbits thus allows a new interpretation of the discrete absorption and emission spectrum. During the transition in hydrogen, for example, from shell 3 to shell 2, a photon is released. The opposite happens when the electron jumps from shell 2 to 3. A photon of that frequency is absorbed. The absorbed or emitted light corresponds in each case to the energy difference between two permitted energy levels in the atom.
Yeah, so keep that in mind. So the actual frequency of the light emitted, or in other words, the vibration frequency, is dependent on the energy difference, and then going back or forward. So if you want to get this back over, you have to send it back into it, basically in resonance to go back here. So it's literally just a vibrating that sphere thingy. We'll go over that after this.
Bohr's postulate of certain permitted electron orbits helped to explain why only certain emission and absorption energies of photons were possible in the atom. However, Bohr could not explain why only these electron orbits were permitted. A step in that direction was made later by Louis de Broglie, who postulated that matter, and electrons in particular, had wave properties. This changed our understanding of an electron from a particle traveling.
Oh, we have the Bill guy, Williams in the show. Okay, let's go. Let's go back here. So now we're gonna go. We went from the Bohr model, and now we're gonna go into matter waves, and then we'll go back to the theory of the Ionel Dinu, because again, I'm pretty sure he's right.
Electron from a particle traveling either left or right to overlapping waves traveling both left and right. These overlapping waves may form a standing wave, which, however,
Okay, let's go back here. So he's saying the particles going around making sense. Okay, how? Oh.
And electrons in particular had wave properties. This changed our understanding of an electron from a particle traveling either left or right to overlapping waves traveling both left and right. These overlapping waves may form a standing wave.
Yeah, it's basically, again, it's just the vibrating object. It's a vibrating sphere. It feels more like harmonics, resonance peaks. Kepler obviously found planetary models, harmonics corresponding to musical harmonics. Yeah, everything.
Which, however, would need certain constructive interference conditions. According to de Broglie, a wavelength lambda is assigned to each pulse p. A constructive interference between waves traveling right and left is given when a multiple of these wavelengths is equal to the circumference. Thus, 2 pi.
Yeah. So basically, now it's based on the circumference of this entire thing, of the sphere, and so the wavelengths is just how many of these can you go in there? How many? I think this is 4 then.
Pi r equals L times lambda. In this example, for L equals 2. This revolutionary idea.
Wait, let's go back. Let's simplify this. What he meant. L is 2. Okay, that's 2 because it goes up and down. I'm trying to. Again, this is why I need to do a video on this where I wrap it around my own way. Because people just say things without actually putting an arrow. What do you mean by 2?
A construct is a wavelength lambda is assigned to each pulse p. A constructive interference between waves traveling right and left is given when a multiple of these wavelengths is equal to the circumference. Thus, 2 pi r equals L times lambda. In this example, for L equals 2. This revolutionary idea allows
L equals 2. So this is I think this is the number of I think it's the number of waves. You have it. This would be starting, ending. Yeah. So basically, this would be the peak, and then you go back to So that's gonna This one, there's 2 wavelengths in here. So this is a wavelength, but there's 2 of them because you can go in one full circle. It's 2 pi r is the circumference. So what happens is if you start from here, you go up out of the circle, go back down, and then go back up. So this is the part where they don't explain. They just state it. So it's basically a sine wave, and now it repeats here. So that's why there's 2.
In this example, for L equals 2. This revolutionary idea allows interpreting Bohr's postulate as a necessary condition for standing waves. The next step towards quantum physics is the question of what this oscillating thing, a term that seems fitting for an electron, is supposed to be, and in particular, in how many dimensions it is oscillating. That standing wave is certainly not 2-dimensional, as in the Bohr atomic model. It is at least 3-dimensional. But that's just the beginning, the dawn of the quantum dimension.
All right, so that's pretty epic. Okay, now we'll go to the spherical here. Okay, now we'll just again, let's recap on spherical harmonics. So I'll be doing a full like multiple videos on this thing. It's gonna be again, I think it's really important. Let's play here.
The spectrum of the vibrating string consists of multiples of the fundamental frequency F0. These specific modes of
Let's go back here. Okay, anyways, so he vibrates the thing. Let's go back here. I was looking at the chat there. Okay, let's play.
Of the vibrating string,
Let's play again. Let's go ready and go.
The spectrum of the vibrating string consists of multiples of the fundamental frequency F0. These specific modes of vibration can be classified according to the number of nodes.
Yeah, so initially it has a big node, and then they start splitting up and getting smaller and smaller. Does the guitar string vibrate or rotate? I think both, but the idea is up and down. Yeah, it depends on. But in theory, you can make it go straight up and down. But in practice, it's very hard to get it straight up and down. But generally, yeah, it's spherical, but also this. And then with time, yeah, so with time, the frequency is become faster frequency, lower amplitude. Well, this is the frequency level, but it's also with time was similar as well. Let's play this. I think that's what they meant, but anyways.
There are generally two different types of framework conditions. There can be either nodes or antinodes at the edge. Physically, this corresponds to either a closed end or an open end. Let us consider the simplest mode of vibration having two open ends. It has one node in the middle and one antinode per each of the two edges. Let us now bend this vibration to form a semicircle. Rotating this semicircle around the z-axis will result in a sphere.
Yeah, so
there is an azimuthal nodal line.
So there's one node here. This is what I mean by the sphere is vibrating. It's literally, it's squeezing in and out.
At the equator of the vibrating sphere. We can perform the same steps for the following resonant frequency, which has two nodes.
Yeah, so notice it goes like here. So it has two nodes, goes up and down. That's what's one full wavelength. Because we have to start up from beginning. So that's two nodes, one wavelength. Don't imagine a wave. Imagine jump ropes going round and round. Interesting. Yeah, that could be as well. But again, there's an oscilloscope. Yeah, that's for another day. Or based on spherical harmonics. Interesting. Yeah, you're ahead of the game, Bill. Just calm down for slow down for a bit. We'll deal with that later.
Let us bend the vibration to a semicircle, and again, let the semicircle rotate around the z-axis. This results in a vibrating sphere having two azimuthal nodal lines.
Yeah. So that's the two wavelengths, and then now squeeze out and in, squeeze out and out. This is again, this is pretty remarkable. I don't know, it just intuitively looks pretty.
We can repeat this on and on. Bending and rotating the vibration with L nodes results in a vibrating sphere with L nodal lines. By definition, these sphere vibrations are rotationally symmetric. They are also their own reflection. Positioning the mirror plane exactly in the middle will result in an identical mirror image. L specifies the total number of azimuthal nodal lines. There is no nodal line for L equals 0.
Yeah, so L is 0 is just the pulsing with no vibrating in any direction.
There is one nodal line for L equals 1. However, this exceptionally symmetrical vibration does not reveal the full range of possibilities, because we can also rotate the nodal line on the sphere.
Okay,
Let's rotate that nodal line to the right, or reflect it to the left.
So this is reflecting the nodal line, but it's not pulsing then.
Now two new modes of vibration on the spherical surface with one.
But how is that vibrating? Is it so it's rotating, but is there any up and down, or is that assumed?
One nodal line. Those are vibrations with an azimuthal nodal line that is rotating clockwise or anti-clockwise.
Okay, so it's rotating, so it doesn't look like it's pulsing then. So that's interesting, so it's like rotate.
In the case of two nodal lines, there is an option to rotate not just one, but both nodal lines to the right and reflect their image to the left.
So you could do it like this. Oh yeah, basically saying the nodal lines you could just shift them around. So there would be pulsing. Yeah, this is. I just don't know why they're just rotating it randomly.
In the case of 3 nodal lines, we can rotate first one line, then 2, then all 3 nodal lines to the right, and reflect their image to the left.
This is part of why I need to like break it down a bit simpler. Yeah, so just moving the nodal lines across the sphere, and you can get random shapes somehow.
There are thus 2L plus 1 potential modes of vibration on the spherical surface with L nodal lines. We can generate any number of basic modes on the 2-dimensional spherical surface by adding and rotating nodal lines, starting from the simplest vibration.
Okay, I just don't like how it's rotating, but there's no vibrating though, just rotating. Is that just assumed it's going to vibrate? I think it's assumed it will vibrate, but they're rotating. We're just moving it around. Okay, and then now we'll go with this last part, this one here. How orbitals arise from atomic wave functions.
How does chemistry describe electrons in an atom? The so-called atomic orbitals are a visualization of the probability of finding an electron at a specific location in the atom. Here, we can see the locations of maximum probability for the s, p, and d orbitals. Behind this probability, there is the invisible vibration in the quantum dimension. This vibration has interference properties. It is visualized here in the form of a spinning wheel. The s orbital is based on the vibration without nodal lines. The p orbital is based on the vibration with one nodal line. Thus, L equals 1.
Yeah. So, okay, so we have confirmed. This rotating thing, it just means that, yeah, you could rotate to the right or rotate to the left, but they'll still be pulsing. In other words, you could rotate along this axis or this axis of that same sphere, yeah. So notice it's pulsing there. So it is pulsing. They just didn't animate the pulsing on the left and right.
Let's analyze the
so you'll just imagine it being pulsed inside there.
Context of the p orbital in more detail. We have already seen the vibrational state L equals 1 on a single spherical shell.
So these ones I would assume would be rotating right and pulsing. I think that's what they meant.
If we slice the space like an onion, we obtain many spherical shells. In space, the nodal line becomes a nodal plane. The maximum vibration amplitude decreases at a very large distance from the nucleus.
Yeah, in other words, this one is not moving much. This one is moving a lot. Like basically, if you think of a bunch of stuff that are being pushed over.
Chemistry does not describe the entire vibration in space, only the location of maximum probability of finding an electron. It corresponds to the points with the greatest vibration amplitude. The result is this representation of the p orbital. This also applies to all other orbitals.
Yeah.
Atomic orbitals in
That's amazing, yeah.
space inherit the nodal lines or nodal surfaces from the quantum dimension. Thus, chemistry and physics go hand in hand.
Yeah. And also notice the different colors. Because this one would be pushing up, this is pushing down, and then you just shade it basically up and down. This one's to the right and left. That's why they're different from the up and down. So this one up and down, they actually made it the same though. Okay, that's interesting. So just using yeah. But anyways, it's pretty much like that, yeah. All right. So that's spherical harmonics. I'm pretty certain, yeah, basically well versed now on it. But I will definitely make a video on it. It's again one of those where you could just kind of definitely grasp, but it's big time. Also erase this. I'll share these on the other places and continue further. Okay, that was this one. We'll do this in case I didn't summarize it last time. Summarize, post it on Telegram here. I'll post it here. These are the ones I just saw, and now that's I'll keep these open just for now in case we need. And then this last one, very difficult to imagine that stuff. Yeah, definitely. Oh yeah, the swords, nunchucks, and 3 sections. Yeah, nunchucks, I remember those. I'll send this over here. Whoops, I can't even send it over. Anyways, we'll do that later. Okay, I'm gonna go quickly here, and then this one, and then this is the on broadcast summarize. All right, so let's go back into the fundamental mumbo jumbos of that. Premium. Okay, this premium. Plus, you get 3 live streaming slots. Okay, so now why? Okay, so now this premium. So I need to get premium. To do that premium, and what's the premium? Okay, and how much do you pay premium? Pay $9 a month. Let's save money with 99. Okay, so $9, 9.99. Yeah, we'll do it later. Okay, so this guy's telling me that. Okay, so anyways, need to get a premium to share to basically do a live stream while scheduling another one, because I'm not doing multiple ones. I'm just see the schedule. Anyways, let's go back here. Fundamentals of Aether Mumbo Jumbos. All right, so we basically understood this part. There's the orbitals. You can make them like this. Just vibrating nothing, and goes there. And then now we're gonna go straight into here. Okay, now we're getting this part here. The new theory explaining the laws of electrostatics by molecular vibration. All right, and then there's all the orbitals and so on. This again, he got it from there. And what's interesting. Last week's live stream, I went over this video before I saw it in his video. Before I went and saw it in his paper. I'm like, what the? He actually said the same thing. Because he mentioned spherical harmonics, and fractal one mentioned it. I'm like, what the? I'll further send this. Yeah, I was gonna say nunchucks here. Nunchucks. That's nunchucks. Electrostatics. Let's go. Yeah, we're gonna go over electrostatics. I'm gonna go with nunchuck. I remember this one. Yeah, this thingy. Yeah, those are some pretty yeah. There's the Bruce Lee guy. Yeah. All right. So let's go here. So the new theory explaining the laws of electrostatics by molecular vibration. So returning to the problem of the laws of electrostatics, we have seen in IVI that for objects of the same size and vibrating with the same frequency, attractions or repulsions occur between them, depending on the vibrations being in opposite phase or in the same phase, respectively. And this tells us that the way in which an object vibrates with respect to another is fundamental for determining their mutual electrostatic behavior. This figure below is reproduced from page 13 of IVI. So this is the one where I discuss this as well, but I want to see an actual visual one where it matters. Then where you can actually see vibrating like diaphragms or plates, and then see if they attract. So if they vibrate such that these are opposite amplitudes, so this is going to the right, this is going to the left. So in other words, and then pushing over like that, these actually attract. And this is the model he made, or he used the fluid dynamics, computational fluid dynamics, and you can see a whole bunch of these particles moving inwards together. So there is some attraction there. So we'll just leave that for. I'll just say I'll assume that's correct, which again pretty much is. You get the fluid dynamics ones, and then this is repulsion. It's all pushing outwards. That's pretty much true. But I just want to. We just have, this is one thing I need an experiment to produce and then validate. In other words, just basically drive the point home. This is what's happening. So anyways, so vibrating stuff here, vibrating, if they vibrate opposite, they attract. And then so it is observed that these surfaces called membranes attract one another. The membranes vibrate towards and away from each other, i.e. in opposite directions, and therefore they should be considered as vibrating in opposite phase. Membranes vibrating in opposite phase attract one another, which is consistent with the laws of electrostatics, unlike charges attract. So unlike attract, and if they're like, they're both the same amplitude direction, so going to the left, this is also going to the left. And then you'll see this right here. This is repulsion. So it is observed that these surfaces called membranes repel one another. Both membranes vibrate to the right and to the left in the same time, i.e. in the same directions, and therefore they should all be considered as vibrating with the same phase. Membranes vibrating in the same phase repel one another, which is consistent with the laws of electrostatics, like charges repel. Yeah, so I think we went over this one. I'm just going to keep reading them, and we went over the metronome, and then we're going to go straight into this part, yeah. So basically, I'm just gonna I'm gonna speed through the parts we already covered, show the metronome video, and then dive right into this other stuff we haven't covered yet. So we'll see how that applies to actual electricity. So repulsions and attractions differ considerably in their probability of occurrence. The former happen within very restrictive conditions, only for similar sizes of vibrating objects. The former. That's the Yeah, so no repulsion. Yes, repulsions happens very, very rare. So we're very restrictive conditions, only for similar sizes of vibrating objects, same frequency of vibration, same or close phases of vibration. The latter happen in more varied circumstances, different sizes of objects, different frequencies, and any phases. But the phases must be opposite if sizes and frequencies are the same. So that's only part. If the sizes, if they're the same size, same frequency, like same basically vibrating rate. Then the phases have to be opposite for attraction to occur. So we arrive therefore at the important conclusion that, statistically speaking, attractions are encountered in more situations than repulsions, a fact that is which is supported by experience and by historical fact discussed in section 2. That electrostatic repulsions were studied long after electrostatic attractions. So repulsions were studied literally like 1,000+ years after. And attractions can be explained by the different sizes of molecules and the different frequencies of their vibration, leading to attractive forces mediated by the ether. Because you have different frequencies, and then you can basically, that's so most of the time they're going to be pushing like towards each other. Repulsions were initially discovered to take place between a pair of identical objects, such as two glass rods rubbed with a pair of identical materials, such as two pieces of silk, and can be explained by the identical sizes of vibrating molecules, whose phases of vibration are initially not correlated, but become correlated through a key mechanism proposed here for the first time. So basically, electrostatic repulsion is very rare. You need to basically have the exact same setup here, exact same charge, vibrating rate and size and so on. That's the only way you get repulsion. This one, you could have smaller sizes, different frequencies, and you're pretty much going to get attraction pretty much all the time. This one, you just need a perfect resonant equal setup and so on. All right, so approaching two energy objects to one another leads to an increasingly stronger coupling through the ether between the vibrating molecules of two objects, which causes the vibrations of the molecules of two objects to become interlocked, synchronize, and occur in the same phase, resulting in mechanical forces of repulsion between two objects. Yeah, basically, yeah. So again, approaching two energy charged objects, you just vibrate. You just rub. Let's see, two glass rods rubbed with a pair of identical materials. So two glass rods rubbed with identical silk, and they start repelling. So basically, approaching two energy charged objects to one another leads to an increasingly stronger coupling through the ether between the vibrating molecules of the two objects, which cause the vibrations of the molecules on the two objects to become interlocked, synchronized, and occur in the same phase, resulting in mechanical forces of repulsion between the two objects. The phenomenon outlined above is called phase synchronization of coupled oscillators and is similar to the ones occurred in coupled macro oscillators, such as the synchronization between two pendulum clocks first observed by Huygens, or the amazing phase synchronization that occurs between two or multiple metronomes coupled by sharing the same support. This is IV3 and IV4. So which one's IV4? I'm gonna go. No, this is IV3. We saw this one earlier. I'm gonna go IV4. This is where they had. They didn't show this one. They had actually. They had multiple ones. And this is also a whole bunch of these metronome. Okay, I'll show all the metronomes. I'll show all these. I only showed one before. But we have so many metronomes. And last, they're still going. This is unbelievable. I didn't realize there's 8 of these. Okay, so I'm gonna play metronomes. I'll see what the speech is.
Metronome.
Okay, metronome. Okay, that's pretty quick. All right. So basically, that's these ones, and they sync up. Let's play them all. So this one we played them before. I'm gonna make it double speed, or faster speed. Yeah. So notice he's vibrating opposite directions, and then he puts on his foam pad, and then there's the I think plastic containers or glass. I don't know. And then basically the vibrating gets resonantly transferred across, and they start vibrating the exact same direction. Play here. I'm gonna fast forward. I'm using the fast forwarding browser extension here. So right now it's at 4 times speed. I can go to 16 times speed. Notice how it's going, and it's gonna sync up soon. Okay, yeah, notice it's synced up. So again, it's synced up where at the beginning it's not synced up. And look at the noise. See, it's like click, 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 and then it goes exactly the same right here. And then puts it back down, it's still the same. So absolutely amazing. Amazing stuff there. I'm gonna see the second one. Okay, there's another one. Synchronization of metronomes. I think they do multiple. Okay, there's multiple ones now. And then he puts, so they're all different. And then you put them all on these containers. Absolutely amazing. It's just so cool. I don't know about you, but I'm like, and I have double speed. I'll keep the noise on so you can hear it. I'll show this. This is pretty amazing. This is absolutely amazing. Okay, let's see what the other videos he has in there. Okay, that's this one. I'll double speed it. I guess one, how a surprising secret of synchronization. Okay, that's a good video maybe to watch. I'll add it to my watch later. Okay, that's from Veritasic. Before they are on the container, they are all separate systems. Once they connect, they are formed one close system that must equalize. Yeah, interesting. Okay, this one's not, video's not available.
So here we have 4 metronome penguins, which can each
Yo,
use
penguins. Okay, we got penguins in the show.
So
Guys.
let's start them up. 1, 2, 3. Here they are. They'll have slightly different phases. But let's wait and see what happens. I'll look at them.
Let's see here. Oops.
So as you can see, they've all synced up
Okay, so they
and
all
are
sync
now
up.
shaking together. So if there were 2 metronomes, like these 2 guys,
Okay, we get the idea. Pretty epic. I'm gonna go and summarize this, put on the blockchain. Again, so we got that. And post that here as well. It's pretty cool because it has text. And let's see the next one. Okay, we have a whole bunch. Alright, okay, this is pretty cool. We just solved electrostatics, guys. See the plate moving back and forth? That's the resonant frequency. Yeah, definitely. It's a plate, and it all vibrates together. This is okay. This is actually amazing. This is actually amazing. Let's play double speed. Notice the noise. Notice the noise, and then it all goes the same exact rate. Alright, okay. This is absolutely astonishing. Okay, let's save this one. Everywhere. This is absolutely amazing, guys. Yeah, I definitely need to upload this as an experiment. It's pretty much straightforward. Alright, the next setup is see that, okay, that's this one. See another one. On a suspended bridge. Okay, now we have a bridge. Okay, yeah, I'm just double speeding. I'm gonna go to Amazon. Let's see if I can buy one. Buy some metronomes. See what the costs are. Metronomes. Okay, Metro. Okay, well, I'll go to the lowest price. Go to Prime. I ain't buying if it's cheap unless you guys want to donate. Metronomes. Not. Okay, I have to like make my own metronome. Okay, this one here, $18, 2 pieces. Okay, that's pretty ridiculous. So if y'all wanna donate, I'll buy this one. If you guys donate, I'll buy it. Otherwise, screw it. Okay, I'll put this right here. Share. So anyways, if you guys donate, I'm buying it. So let me know if you guys if I should buy this. See the plate moving back and forth. Yeah, definitely. Donate, guys, to the MES.fm/donate, and I'll buy it. Because I don't want to spend too much. The resonance between the swing and metronome and the swing on the plate. Yeah. The cool thing is it occurs on every single one, which is absolutely ridiculous, absolutely remarkable. There, how it does that all. Which again, the whole idea is we're literally talking. This is how electrostatics are. This is it's pretty much how everything is. Okay, and there's another one here. Let's play here. Oh, it's 100 metronomes. So this is 100 of them, guys. This is absolutely surreal. All right. And the thing is, this occurs not just with rotation, but I mean vibration, but rotation as well. That's what I'll show you soon. Because this is I realize it's so cool. All right, we're on another level, guys. Okay, let's see the next one. It's gonna keep going. Oh, I thought it was gonna go do like 1,000 or something. Okay, it's another one. Spontaneous synchronization. All right. Anyways, that's that one. I was gonna say right here. Donate. Anyways, guys, if you want me to buy that Amazon one, donate. I'll do some videos and so on. Donate to the throw some money at me, you can do become superfan, Patreon, or PayPal directly, or get sent to me some crypto, etc. All right, anyways, that's enough.
This mechanical
Let's see what this guy's doing right here.
metronome works by swinging a pendulum back and forth.
Okay, it's keep going on.
Some small amount. Breathing in and letting it work out the resonance frequency.
Okay, we're pretty much drove the point home. Okay, that's pretty amazing stuff. Okay, let's go now. So the pictures below are from IV3-2, where it can be seen that metronomes in black initially oscillating in opposite phases end up oscillating in the same phase due to the strong coupling between them caused by the transmission of oscillations through their common support, the white board, in other words, ether. In electrostatic interactions, the two metronomes have represented two molecules on two similar charged objects. So basically, now you have the molecules. Basically, this is what they represent. On two similarly charged objects. The molecules have similar sizes and the same quantity of electrogen, therefore will vibrate with the same natural frequency. Okay, so this explains groupthink and hive mind. Actually, before I do this one, in threads, I actually shared someone here. Basically it is groupthink and everything. People just go with the flow. Someone made a post about that. Where does it go? It was on threads. I retweeted it. How do I find a retweet? I can't even find a retweet. It's ridiculous. Well, what's the point of you can't even find retweets? Reposts. Okay, this one. This one here. Yeah. So when you think your circle of friends, doesn't influence you, watch this video. Yeah. Y'all know this is it. Okay, so you know the drill, guys. Okay, and late again, babysitting grandkids in a hectic and rewarding job. Epic stuff. Yeah. So sounds pretty fun there, Tammy. Yeah, and Tammy, as I said earlier, for those just joined. So I'll be doing the Saturday live streams like once every other week, so I can have more time to prepare. But I'll be publishing the trailers instead of making unlisted, so that y'all can have you can send me your thoughts and links and info beforehand, so I have a whole week to prepare, so no rushing. All right, guys, and this guy's pretty ridiculous. All right, let's go back here. Okay, I'll just close this. Okay, so let's go back here. So I'll keep the email open just in case someone sends me emails about the stream. Okay, so in electrostatic interactions, the two metronomes above represent two molecules. So basically, you have the sphericals vibrating. On two similarly charged objects. The molecules have similar sizes and the same quantity of electrogen. That's a vibrating, that's an extra element, electrogen generating element, and so on. Therefore, will vibrate with the same natural frequency. Their approachment causes a strong coupling through the ether that transmits their to and fro motions, and they will end up vibrating in the same phase, and therefore end up repelling each other. So if you have something like that, what's connected by that, they're actually going to repel each other when it's that's something. So that basically shows you how repulsion would be looking like. But the thing is, I still need to see a vibrating plate same phase in water or something and see what happens. What my favorite Saturday activity is now bi-weekly. It just helps me prepare and so on. It was all mainly because 2 weeks ago that live stream about the Renee Good one, I was I just can't say the full context. It's ridiculous, but that was the hardest stream I did. If I ever meet you guys in private, I'll tell you. I won't put it in typing because I don't want this to be known. Anyways. Oh man, it's pretty funny. But anyways, so yes, if I ever see you in person, I'll explain why. But anyways, so I just need to prepare more, and give you guys a chance to, and it also saves me a lot of a headache and so on. Anyways, so yeah. So if I ever see you, I just can't say. Oh man. Anyways, so all right, let's continue further, guys. Okay. Anyway, so in electrostatic interactions, the two metronomes above represent two molecules on two similarly charged particles. The molecules of similar sizes, same quantity of electrogen, therefore will vibrate in the same natural frequency. That's where I'm laughing with. Okay, yeah. Okay, therefore will vibrate with the same natural frequency. Their approachment causes a strong coupling through the ether that transmits their to and fro motions. and they will end up vibrating in the same phase and therefore end up repelling each other, irrespective of their initial phase of oscillation. That is, even if their initial phase of oscillation are opposite. If they're initially opposite, but they end up phase locking like this, they're going to sub-repelling. You pair well with your frequent guests. It's not about the guests. It's about... anyways, yeah. You pair well, yeah. Well, no, I'll still have frequent guests, yeah. Frequent guests, those could be more weekly. But again, even then, it gives me more time. Okay, order dispatched. Okay. Oh, we got some tape. Okay. Yeah, it just gives me more time, guys. Alright. Oh, actually, speaking about this, I'll do that later. Anyways, anyways, the study of coupled oscillators has been extended to more complex systems such as biological organisms and collectivities of animals or humans. Yeah, so it even tells about that humans, coupled oscillators, including humans. And interesting mathematical models have been developed. One of which is the Kuramoto model. That's II5. Coupled oscillators that synchronize themselves. So this is interesting. Okay, and then they have some computer models to it, but also remember humans and animals too. It's not just other people.
So let me show you a video of a case of unwanted synchronization.
Oh, this is a bridge collapse and so on.
It occurred a few years ago, actually now 11 years ago, on the Millennium Bridge in London. Do people know this story? Put your hand up if you've heard this story. Okay, so most of you have heard it, but how many of you have seen footage of opening day? Oh, a few, okay. So here's the story. There's this beautiful bridge in London. Some of you may have walked across it. That was built to commemorate the millennium. And it's a footbridge across the Thames from St. Paul's Cathedral on one side, the Tate Modern Museum is on the other side of the river. There was a building which has been described, he described it himself, spectacular. Normally with a suspension, these big droopy cables on the top, as if you hate holding by the top, they're not affected with a bridge. Now,
okay, let's see. Okay, yeah, I'm gonna go to the bridge. Okay, what is that? Millennium Bridge. Okay, Millennium Bridge. I'm gonna go see the footage. Millennium Bridge. You can see the footage of it. Wobbling. Bridge closed days after opening. Let's see how that was.
London's Millennium Footbridge was open for business again today, but the bouncing bridge, as it's being called because it moves in the wind, will have to shut for an indefinite period to allow the problems to be sorted out. The builders stressed that it is safe for the public, though the numbers crossing today were being restricted on both sides of the Thames. At the weekend opening, a combination of strong winds and big
it's like literally moving.
crowds caused it to be closed for several hours. Cynics are comparing the Millennium Bridge with the ill-starred Millennium Dome down the river. The architects say that as a
Yeah, Millennium, everything is 2000. Holy, this is actually
suspension bridge,
that's a lot of code in this.
it was always intended to move.
Yeah, that's pretty. They were not determined by the sway. Like these people are people insane. Like get out for that. Anyways, so that's a pretty interesting bridge, and also Millennium, and it's a Millennium Dome, and it's 2000, and it's wobbling again. It's a precursor of 9/11. I'm telling you, get ready. The century's gonna be wobbling. All right. Okay, so that's pretty cool. Let's go back here. So the theory of two charged. I also want to copy this one as well. This is I want to put this on the blockchain mainly. Summarize this thingy there, and this again mainly just put on the blockchain. We'll summarize it as we go. Anyways, so the theory of two charged objects of similar size repelling each other through phase synchronization of their vibrations due to strong coupling through the ether and of attractions between objects in any other cases. So basically, there's attraction in any other case of vibration. This is the only one that's repulsion. And this one I need to see. I definitely want to demonstrate this through experiments. And of attraction between objects in any other case, it leads to the reformulation of the electrostatic phenomenon listed at the beginning of the previous section in terms of molecular vibration. And here it is. And yeah, now we're getting into the nitty gritty. So in electrostatics, right here, I'm going to drink some water. I'm going to start standing, and then we'll power through this. Oh man. All right. Stand up. Okay. Let's power through. All right, so let's go right here. Here's the new from reformulation of everything. So electrostatics formulation. Here's the mainstream electrostatics. Attraction between a body positively charged and one negatively charged. But again, even this is as I stated before, if you have a body that's bigger than a smaller one, it will still attract it, even if they're the same charge actually. Fractal woman interviewed John McKinnon about laser gyros, and you got to learn how they work. It explains a lot. Interesting. Yeah, I think I've heard about laser gyros. I've looked at it a bit. It's pretty fascinating. All right, anyways, let's go back here. First Mackin interview. Yeah, that's I'll add that to my mental brain. Anyways, so here's the mainstream. Mainstream is this attraction is between body positively and negatively charged. In other words, they don't explain it. Molecular vibration from reformulation or formulation. Attraction between a body with a deficit of electrogen in vibration and one with a surplus of electrogen in vibration. So basically, yeah, if you have one that's vibrating, one that's vibrating and one that's this is attraction between deficit, one that's not vibrating as much, deficit or that's attraction. Oh no, that's this one here between bodily positive. This one's the negative. Oh, this is a negative one. So negative charge is basically one that's not vibrating, or one that is. Let's see what is it. No, in this case, body positively charged has a deficit, but it doesn't actually specify which one is which. Okay, anyways, so this one here, so mainstream one, you have a plus and minus, they attract. This one here you have one that's vibrating and one that's not vibrating. In other words, the electrogen that's surrounding the atoms, molecules, is vibrating, and one that's not, they attract. Now, if you have an attraction between a body positively charged. Okay, let's see right here. Tammy says, your bi-weekly Saturdays will not encourage me to increase my time spent with Martin Fleischman. Bob seems very driven to pat himself on the back these days. He seems like a decent guy enough, but something's off. Yeah, again, the interactions with Ashton Forbes is just ridiculous. And also, apparently, his dad or grandpa is a Freemason. Bob Greer's is like a 33 or 32 degree Freemason or something. That's pretty interesting. But nonetheless, again, it just Ashton Forbes' part is just ridiculous. I can't take it. Like yeah, yeah. Like you have to realize I'm literally on the receiving end of him lying through his teeth to his like 100,000 followers on X about me. Like literally again to illustrate how big of a like clown he is. He's literally lying about me, okay, tagging me and pretending like and blocking me so he doesn't just, or just like muting me so he doesn't even see it. So let's go Ashton MES. This one right here. So literally he tweets. He tweets right here. He says that the other fun part was the guy platforming him as Matthew's Solutions, a 9/11 conspiracy nut job. This guy's an MH370 teleportation nut job. He's calling me a nut job. And he says, who went dark after Joe Lancaster was exposed. No, I didn't go dark. I've been calling Ashton Forbes the clown almost every single stream ever. I just want to work with everyone. No, it's all right. But I'm just saying, Ashton Forbes is literally lying about me to me. Okay, like they're tagging me and lying about me. Like, so what I'm trying to say is, it's like, like I know he's a clown. He's lying about me. And in other words, I feel exactly how Joe Lancaster feels because I'm 100% certain he made the videos. It's literally like this is how I feel. Like he's literally lying about me. He's saying I went dark. I didn't go dark. I literally replied to him right away. Thanks for the shout out and unblocking me, Ashton. So it's like and so on. And yeah, again, the guy's an absolute again. You have to realize he's lying about me to me. To his like 100,000 plus followers and so on. So it's like, what do you want me to do? All right, so I'm doing the stream right now, calling him a clown. I didn't go dark. It's like, what do you mean dark? I've been streaming every week. I've been doing a live stream, calling him a clown. All right, anyways, guys, let's continue further. So the second part here, attraction between a body positively charged and one uncharged. Again, this is where you need to graph these out. You can't just stay them. Like writing these out is just ridiculous. So actually, I could draw that out. Okay, so we're gonna have the first drawing out in quite a while, and I'll pull this out, guys. I have I'll pull up my notes. 1 second. I'm just gonna plug this in because I have this plugged in. I'm gonna plug my notepad in. You're gonna plug this in, and then we're gonna draw these out because I need to 100% confirm what in the world's going on here. All right, so we have that, and I'm gonna open up this this thingy. This was 1 second. I'll go over. This was I was working on the Gulf of Mexico stuff for the John Hutchison and Nancy's thingy. Okay, I'm gonna go to where's math Q&A. We'll do one here. Oh, the last one was radio waves. What are the odds? The last one that I had notes on. I'm gonna go above. I'm gonna call this 53. I'm gonna go Ionel Dinu Aether. Electricity, vibration of charge wires vibrating at a pitch you cannot hear. This is why strings tied together works. Vibration is what is conduct. Yeah. Again, but he's saying that the vibration is the electrogen that's surrounding the wires, the atoms and so on. So I'm gonna go right here. I'm gonna start coloring this in right here. Okay, it's okay. Let's see if it works here. I'm gonna do this. Okay, so on the left side, we're gonna draw the right side. This is the mainstream science one, and I'll draw this out. So attraction between a body positively charged. So here is I. Okay, so I, you have this. You have a plus, and then you have a minus, and then now you have attraction. They both go towards. Okay, I've been replacing electrogen with vibration while you read. Yeah, no, that the electrogen is the vibrating thingy. Yeah, so electrogen is the vibrating thingy around it, and basically electrons it's the electrogen. It is not electrons. It's the electrogen that's surrounding the atom. That's the vibrating thing. Though like that as well. However, through a series of events, I learned the hard way that some people are quite removed from the image they present. Interesting. Okay, what are you talking? Somebody else. Oh, we want to work with everybody. Yeah. We're working with everybody, but again, when the person that's literally lying about me personally, like I don't care what he's done. He's lying about me, like straight up. There's no like imagine someone's lying about you directly. So anyways, this is I. That's the mainstream one, and then I'll just do now setup. I'll do it like this. That's I'll open up like this. Okay, that's mainstream is attraction like that, and now the other one is the his one. I'll draw with the right hand his one. Attraction between a body with a deficit of electrogen and one. So now you have a body that has electrogen. This is back and forth, vibrating, and this one doesn't have. This one has deficit. Okay, I'm getting a call from. You know I'm doing live streams. 1 second. Okay. Yeah, does ring a bell have a field? No, I know that's a macro thingy. That's a macro setup. What I'm trying to say is the thing even like he says even the atoms vibrating can act like the charge. But what he's saying is that the electron is actually it's actually electrogen. It's actually the fluid that's vibrating. So in other words, electron isn't just a random it's the actual spherical thingy. But the atoms themselves can act like charges if they're vibrating. That's why you can have those macro ones. Like the metronomes is just like a macro charge. So now if you have a small one. Oh, this is. I'll just get a small one. This is small. Yeah, and this is attraction. And something like that. Anyways. So attraction between a body negatively charged and one uncharged. That is this right here. Okay, so now this one here, attraction between a bodily positively charged, one uncharged. That's let's see, this is just the attraction here. Positively charged. Now this is I2. Now you have plus, and then plus like this. Yeah, you have a plus here. No, actually, this is uncharged. This is neutral. This is just an object. So plus attracts anything else. Yeah, so these are pretty much attracting each other. That's attraction. And now the other one is attraction between a deficit of electrogen and vibration, one with electrogen not vibrating at all. And that's, yeah, basically negative charge is basically one just doesn't have much relative to the other one. Now you have this one here vibrating. Okay, this is I just did a back and forth vibrating thing, and then this is going to be attracting one that's not vibrating. There's nothing vibrating around it, and this is attraction. All right, next one. Let's see the next setup here. So attraction between a body negatively charged and one uncharged. So now you have this one here. Yeah, so this is he's doing every single type. Because these guys say if there's negative charges. Now you have a body negative charge. Now you have a minus, and then it attracts an uncharged. So negative and positive both attract uncharged. And now the other one would be the same one here. You just have see what he says here. Attraction between a body with surplus of electrogen in vibrating and one with electrogen not vibrating at all. Oh, there's a deficit of electrogen. Okay, what does this mean? No, deficit of electrogen in vibration. Oh, okay, I got this one wrong. This is the yeah, okay, this is wrong. So a body positively charged. Oh, because electrogen is negative charge. Okay, that makes sense. So this one here is a body positively charged and one not. So this is gonna be with deficit of electrogen. So it doesn't have much electrogen. I got this one wrong. This one's wrong. This one's wrong. I have to erase this. Eraser. Erase this. Whoops. I'll just use this thing. Erase this. Erase this part here. So these ones are wrong. Because he's saying that, yeah, so positive charge is one that's not vibrating much, or deficit of it. Okay, so now it's deficit. Basically, it has like doesn't have much electrogen. 10. Let's go back here now. Okay, so this one's gonna be so attraction between a body with a deficit of electrogen, so it doesn't have much. I'll just say there's like no electrogen, so it's gonna be like a void in the ether. Yeah, there's like nothing around it. It's nothing in vibration, but it's a deficit and it's vibrating, so this whole thing's vibrating as well. So yeah, so the object itself is vibrating, and one with surplus electrogen. This one's surplus. This one is the negative charge. So this is negative one, and this is the vibrating. And they're both vibrating. They tracked. Okay, this is one we need to like simplify a bit more. Attraction between a body with deficit of electrogen in vibration and one with electrogen not vibrating at all. So this one is there's no vibrating. This one has electrogen, but it's not vibrating. This one has electrogen, but it's not vibrating. This one is a deficit. Okay, the deficit part is the one that's interesting. I think he kind of means that there's like a void in the ether, and this is vibrating, or there's nothing in there, but this thing is vibrating. This is I gotta wrap my head around. This is what I try to get him on the stream. It'd be good to have him in there. Now the other part here is repulsion between two bodies. Oh, that's the third one here. Oh, the surplus electrogen vibration one with vibrating. Oh no, I got this wrong. Okay, this is 1 second. I gotta erase this. It's kind of why I do these videos. To force myself to get these right. Yeah. Let's go back here. Okay, this is the second one. This one, attraction between a body with deficit of electrogen in vibration. So this one has a deficit. This one's the same thing as this one here. So the positive charge just has like barely any put it like that, barely any, and the whole thing is vibrating still. The whole atom's vibrating. So the body's vibrating, and one with electrogen not vibrating at all. So now one with electrogen, but they're not vibrating. But it's not vibrating. This one, this attracts. Yeah, so a non-vibrating positive charge would be a positively biased material not vibrating. No, a non-vibrating positive charge. Yeah, so in this case, in mainstream this is positive charge. So, but a positive charge in his view doesn't have much electrogen. Basically, there's no electrogen there. It becomes like a void, kind of like it's like a void in the ether. Positive charge would be a positively biased material not vibrating. No, the vibrating it's separate. I think it's separate, yeah. So if it's vibrating, it can be separate. They're just saying electrogen is itself. It can vibrate, but it's also, that's pretty much like, it's kind of like water. We'll get to that in a bit. I just want to wrap this around because he has some better examples as we go through. So anyways, so the next part here, attraction between a body with surplus of electrogen and vibration, that's a negative, and one with electrogen not vibrating at all. So basically, it needs electrogen for it to attract, according to this thing. If there's not if there's no vibrating, it needs electrogen. So this one is a surplus in vibration. So the whole thing's vibrating, and it has that. This will attract one that has electrogen but not vibrating. Whoops. How do I do undo? Home undo. There's no undo button. Okay, there's undo. And this one's gonna be has but not vibrating. So that's this part here. Okay, and now let's see the next one. Repulsion between two positively charged bodies. But this is not fully true because you can actually have attraction. So this is IV. Okay, this is repulsion between two positively charged. I'll do the IV and the V one. So positively charged, this is going to be repulsion. So they're both going to be pushing outwards. All right, so the force is outwards. And then V, you'll have two negative, also push out. And then now we'll do the vibrating here. Atoms, regardless of their form, are always in motion. The striking of a bell is an excitation no different than an atom in the outer shell, ready for interactivities. Yeah, definitely. Its existence, it has to be motion. Yeah. So they're always moving. It just is but like phase locking. So repulsion between two bodies. And now we're going to part where. Yeah, now it's the repulsion part. Repulsion between two positively repulsion between two bodies of similar sizes with deficit of electrogen and vibration, where the vibrations are in the same phase due to the phase synchronization and through strong coupling through the ether. So so this part right here, we'll draw this one out here. This is going to be basically deficit. I'll draw like a double line for deficit. Basically, there's no electrogen there. So when there's no electrogen, the ether's like compressing it there, and this is in vibrating in the exact same phase as this one here. Okay, and then this is going to be if this is right. And then left is the exact same phase, right? Like I'll just say, I'll draw a parallel line. I'll put a line like this, just meaning phase. This is an arrow, not a plus sign. And then this is going to be pushing outwards. And then the second part is attraction that may occur between two bodies with surplus or deficit of electrogen and vibration. No, that's this part here. Repulsion between two bodies of similar sizes with surplus of electrogen and vibration, where the vibration are the same phase due to phase synchronization through strong coupling. Yeah, so you have the same phase, same thing, but now you have a lot of electrogen. So a lot of electrogen basically means you're pushing the ether out. So there's a lot of electrogen on it. That's the negative charge. So basically, electron is the electrogen. That's pretty much what he's saying. I'm pretty sure. So now this is the body itself is vibrating. You could say it's the electrogen vibrating or that's vibrating. It's the same thing. I'll just put it like this, so it's like the same thing. This is oops. But yeah, put it like this. Same phase as this one here, and put it like that. Whoops. Anyways, this is a really rough drawing. But the force is outwards. This is for myself mainly. I'll do a screenshot of this and put it in the thingy. So is electrogen like electrostatic electric field of an electrolyte? And I'm not sure what an electrolyte is. No, I'm pretty sure he means electron is the electrogen. Like electron is pretty much electrogen, as opposed to electron just being this random particle. This pretty much like wraps around the ether. So like I'll show you this water. So this is the electrogen. If you put on water, it sticks to water. Like I showed before, if you have a paper towel, wet it sticks to it. So this is like if the atom would be the inside instead of a positive charge, the atom is just the matter. And now you have this actual the actual electron. So because in this case, yeah, he doesn't really this electron pretty much is a bunch of electrogen, I think. So anyways, we go back here. Now this is the one where it gets interesting. So attraction that may occur between two bodies that have the charges of the same sign, but with the charge on one of them relatively weak. So this is the one where mainstream doesn't really explain why too much. Because if you have this right here, because you can have an attraction right here. If you have VI, if you have a plus big one, let's say the plus is really big, and then you have a the same charges, but the one is relatively small. So if you have with the charge on one of them relatively small, so you have actually instead of I could just do it doesn't have to be different size. It could be the same size. It just has one of them. Say you have a charge like this. Let's say this is a super big charge, plus, and the other one has a super tiny charge. There's still attraction. So in other words, like material, like charges attract. And now this is according to his. Attraction may occur between two bodies with surplus or deficit of electrogen in vibration, but the electrogen vibration is different in frequency and amplitude due to the different amounts of electrogen surplus or deficit. Yeah. So this is attraction there, and also this one here, and also the negative side too. So you can have the like one still attract, and if you have whoops, I'll draw this better. Okay, now I'll use my right hand. I was using left hand. This is a giant negative attracts a tiny negative charge. All right, and then in his case, basically, if they're out of phase, they will attract, as long as they're not in phase and different, same size. So, but the electrogen vibration, different frequency and amplitude due to the different amounts of electrogen. Yeah. So now you have this case. In his case, it will be like this. Let's say you have the plus one has a deficit, so I'll just do a double line. Basically, like there's no electrogen there, so it's like the ether is compact. And the vibrating, this one would be, let's say, this is a plus one. Okay, so now we have this one here. Let's say there's another one here. That's also that's also has this here, but the phases are different. Let's say this one here, it has a bigger amplitude, and this one has a small amplitude. So the vibrating radius is smaller. This will still attract. So these will still attract here. So they will still come together. And then, and likewise, if you have a lot of electrogen, the whole idea is it's rarefaction. The other one's compression of the ether is rarefaction. Again, this is just think about the electron orbital we're talking about. That's just pretty much it. So this is, let's say you have a different phase, and this other one you can have it as long as it's different amplitude or different phase, etc. Different as you can have it like small like that, and I'll actually make it this one's also, yeah, this is a positive charge. This is the negative one, has a lot of electron, and shift it over. Yeah, I'll do this like this, and there's a lot of electrogen. This could be again different phase than this one. So these ones and this ones are different phase, and this will attract. And this one is, yeah, just say it's like much bigger or smaller, and you're gonna attract. All right, so that's it. That's all. I'm gonna do a screenshot. I'll do a zoom out. Okay, I'll do a screenshot of this just so I can grasp this. Grasp it for future takes. This is what I mean. People have to realize it's like whatever you put a wall of text, like make a video. I mean, make a video / image something. That's why if you ever see my thumbnails from my math videos, I spend a lot of time on those to make sure it's top notch. Okay, so that's that part. I'm gonna post the photo here, and I'll post this photo here. I might even make it a better one, and then add it to his actual paper. Yeah, so I might do that actually as well. Anyways, guys. Oh, this also needs updated. This needs to be indicating that. So the cool thing about to put on the Hive blockchain, I put it like this, indicating that, and then just delete this space. Okay. So now we're fix that up, and also get on the Hive blockchain. Okay, CCW not cow. Okay, what is that? Oh, it is the CO. An electrolyte is like a magnet, but with a static electric, not magnetic field. Interesting. Well, in his case, magnetic field is just rotation of the ether. So the other one's vibrating, other one's rotating. Again, I'm going super simple because I'm like I think because again this guy has a patent on anti-gravity device, which I want to replicate. So here at MES we go step by step, indicating that, and then anyway, so we go here, and also this on Hive blockchain, and I got Fractal Woman on, and she's been posting her book now on. So guys, get on Fractal Woman's, follow her on Peak or on Hive right now, and so she's got followers there. She's starting to put her book as well. Introduction of, I think she said introduction of a book. Okay, this is a prelude of a book she's writing. Prelude, I think she meant book. Okay, this book's about the fractal nature of the universe and so on. So you can see all of her writings on here. So she has a whole bunch. And this guy here is I'm pretty sure he's a disinfo agent. He's interacting with everybody though. That's anyways. So yeah, so you can go follow Fractal Woman. Get on the Hive blockchain. If you have trouble figuring out how to get on it, let me know. I'll make an account for you, and so on. So we got Fractal Woman taking over the game. Like, look at this. She's putting all of her stuff in there, and also she needs to claim her rewards. Oh, 68 cents. Oh, she has been claiming. Okay, so she actually claimed 3 days ago. Okay, epic stuff. So her account's already worth 68 cents already. Like, again, Hive is the easiest way to make money on the internet. It's literally just go in, post. Allow viewers stream. But what is this guy saying? Hold the message for a reason. Okay, allow. No, deny. Deny. Okay, so there's a comment on Twitch. Okay, so that's this part here. Definitely get on her setup there. Okay, so smartest woman on Earth. Yeah, definitely. She is pretty smart. Okay, let's take over the game. Okay. So anyways, going back here. So we're back here. So now we're gonna go into how this corresponds to electricity, like where a wire somehow can do things to your like power stuff. Okay, we're getting some messages. Okay, this should be removed. Okay, so anyways, interesting clues on the behavior of matter with excess and deficit of electrogen in a state of vibration can be obtained from the study of discharges of electricity through gases at very low pressure. So discharge of electricity through gas at very low pressure. As can be seen from the picture below, is IV6 comments added, so he added these comments. So if you have a plus, and this is a wire, I would assume, and there's a minus. So minus has a lot of electrogen. This one has very little. So he says right here, and this is a, so interesting clues on the behavior of matter with excess. Wait, Burn Eye, i.e. Crypto Alchemy, has scheduled a rant on Jeremy Reese. What do you mean a rant on him? He didn't listen to the warnings, unfortunately. He scheduled a rant on Jeremy. What's he ranting about? Like, Jeremy Reese is white his girlfriend 10 years ago with a machete or something. Anyways, that's for another day. I'm saying apparently because, well, I don't know. I haven't looked at it too personally, but I'm pretty sure that's what happened. So anyways, check that out. That is interesting. Okay. So anyways, interesting clues on the behavior of matter with excess and deficit of electrogen in a state of vibration can be obtained through the study of discharges of electricity through gases at very low pressure. So here's gas. Imagine there's a gas in here. As can be seen from the picture below, the discharge at the positive metallic electrode. So positive one has a lot of positive one has very little electrogen. So a discharge at the positive metal electrode at the positive has there's no space between a discharge and metal at the positive electrode. So there's no space between discharge and metal. So there's a metal. There's no space between them at the end at the positive electrode. I gotta wrap my head around this. Discharge at the positive metallic electrode starts from the surface of the metal, indicating that the vibrations there are produced by matter with deficit of electrogen, while at the negative metallic electrode, there is a space between the metal. So this is at the negative one. So I just want to represent okay. So the discharge at the positive. What do you mean again? Discharge. What do you mean by discharge? At the positive metallic electrode starts from the surface of the metal. So there's a surface. Yeah. Oh, yeah. This is what I mean. Okay. So this is where the sparks come in here. The sparks come at the surface of this metal right here. So no space between discharge and metal at the positive electrode. So there's no space between discharge. Oh, that's what it meant. Okay. So the discharge is on the metal. The discharge is on the metal. So this is actually an amazing clue. So think about what he just said. The there's electric arc or whatever, electric discharge, electric lightning or whatever, electricity. That's on the actual metal at the positive electrode. Okay, Jeremy Reese did him dirty. Interesting. Yeah, well, Jeremy Reese, well, if Crypto Alchemy, actually, if he wants to be joining my stream, tell Crypto Alchemy he can join my stream probably in 3 weeks to rant about Jeremy. Like a Tesco, okay. So keep this in mind. Okay, so at the positive one, it's at the metal. This is actually a very, very again, this guy, I'm telling you, y'all, Ionel Dinu is a real deal. Okay, so the discharge is right here at the positive one, indicating that the vibrations there are produced by matter with deficit of electrons. So in other words, electrogen. So basically, this is produced by matter that doesn't have much electrogen on it, so it's at the metal. So in other words, the actual metal is vibrating. While at the negative metallic electrode, there is a space between the metal surface and the discharge, indicating that they're okay, this is a typo he made, indicating that the vibrations are produced by the surplus of electrogen on the negative electrode. So there it is. The negative one has a bunch of electrons there, but notice the discharge is around this. It's not right on the metal. So in other words, the vibration is from the electrogen. This one's vibrating is from the metal because it doesn't have much electrogen. So this is okay. We have taken over the game, guys. Yeah. So yeah, definitely. Sounds good. Tell Crypto Alchemist anything about that Jeremy Reese guy. Jeremy Reese guy again. Yeah, Jeremy Reese. You can go Reese on my thingy here. Let's go wife. Wife. Whoops. Jeremy, how do you spell his name? Alien scientist, and he's also part of the. Also was part of the military. Let's go alien scientist. Let's go custody. Yeah, so apparently, Jeremy Reese, aka Alien Science, is also currently involved in multiple court cases right now involving domestic abuse and a divorce, custody of his children, and apparently served in the military too. I've confirmed that this is indeed Jeremy by looking at his previous X account. So you have this woman here. It's hard to see this right here. This is Jeremy Reese, Rhode Island, court case, and then bail transfer. Criminal. So it's actually a criminal complaint filed. Misdemeanor, domestic violence. Okay, so we got some domestic violence on him. Yeah, domestic violence right here. Jeremy, and he was in Bristol. Remember the Bristol there? If you go to his LinkedIn, it says Rhode Island, alienscientist.com. Bristol, this is Bristol County is in Rhode Island. Jeremy Reese, and he sees here Rhode Island, so on. That's from his the report of the thing. And it says Bristol County, Jeremy Robert versus Jeremy Robert Reese versus Canton Brittany Joyce. Complaint of for custody support. Oh, so custody, he's not paying for custody again, or custody support. Parenting time applies to Jeremy Reese. Okay, plaintiff. No, he's a plaintiff. So is he? So he's filing the docket against her. So now he's going against her for custody for parenting time. An affidavit as to military service. So again, he has affidavit of military service. Yeah, dang. Yeah. So anyways, the guy is but also here I saw this from his X account. It's 2020. Going to watch movie tonight with Brittany after the kids go to bed. Yeah, my latest piece of artwork. Yeah, so that's Brittany, and there's Brittany. Yeah, that's you put the two and two together, and he's filing complaint. He's not getting enough. So he's filing complaint for custody support, parenting time. So so she got the. So she has like main custody, primary custody of the kids, not him. Think about that. And then parenting time. He wants more parenting time and so on. So again, pretty wild stuff. That's 2024. So yeah, so that's Jeremy Reese for y'all. And you wonder why in the world is he in the free energy / 9/11 cover up game. So that's the way it works there. Oh, I should have been here actually. Put in the wrong thing. Whoops. This just goes here. No, this goes here. Okay, this is this part. I'm gonna delete this one here. Delete the first one. Delete. Yeah, again. Just keeping the kids from him, but again, there's a criminal complaint or something. Apparently, you can go ask him. I brought it up one time, but there's also another part where he's chasing. I think 10 years ago, as a girlfriend with the machete. That was according to Andrew Johnson was interviewed. Not Andrew Johnson. It was according to that Edgar Fouché. So Edgar Fouché, but I couldn't find the exact thing. Andrew Johnson said Edgar Fouché. Edgar Fouché, the one that Jeremy Reese had him on. No, is it what's his name? Edgar Fouché, the guy with the TR3B. TR3B. How do you? Okay, my goodness. Quasi crystals. I made one. So I wrote one about quasi crystals right here. So this guy right here. If you go, I wrote about quasi crystals and so on. I wrote about the math about them here and so on. And I was gonna buy this quasi crystal thing. And this Edgar Fouché. Yeah, this guy here. Edgar Rochelle Fouché is his name. He says it's not related to Rochelle. It just happens to have that. Anyways, so the TR3B guy. Yeah, so Andrew Johnson actually said that Edgar Fouché like visited I think something like this. Don't quote on me, but tell them something along the lines that he actually was in contact with Jimmy Reese while he was in prison. Jimmy Reese in prison, and apparently it was for chasing his girlfriend with a machete or something. Think about that. That's this guy here, the guy with TR3B, where Jimmy Reese had him on. So this guy right here. See that Jimmy Reese chasing his girlfriend with a machete like 10 years ago or something else. Typical narrative of those sitting in the cover-ups, Greer or Patsy. Yeah. So that's why here at MES, you don't go if you cover up 9/11 or you come after me, you're gonna get, well, you bet make sure your background is squeaky clean, because you're gonna get like you're gonna get ridiculed. Anyway, you're gonna get exposed. Anyways, guys, let's go back here. This guy's onto something. Okay, so this is pretty big. This is absolutely massive. I need to see this right here. I'm gonna go right here. I want to see this again. This is a drawing. I want to see this actually. Matters excess electricity in the state of vibration through study discharges through gases at low pressure. Okay, discharge of electricity through gases at low pressure. Okay, let's see a video on this. This is a magnificent. Okay, okay, there is some modern physics discharge of electricity through gases. And in the drawings, they don't. Let's see. Let's see if he's onto something big. Why do they put music on? Okay, I'm gonna go right here. Another thing I want to show is this. I want to take this image. This image is very, 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 very telling. This, bombshell images, guys. Okay, I'll put this right here, and I'll put a link to this. Just because this is pretty big, guys. I want to do that. I'll go right here, and then I'll do that image again. Copy image. This is important stuff, guys. Post it on this. All right, this is some fascinating stuff. Okay. All right, that's that part. Okay, so let's go back here. So moreover, yeah, so go back here. Yeah, okay, yeah, I wanted to go to this video. Modern, let's go back here. I'm gonna close some stuff. Okay, this is the metronome I want to get. Let me know, guys, if you wanna send some cash money, add me. So I'm just order it now. I think we're just gonna order it. Okay, anyways, y'all, it's ordered. Oh, this is metronome sliding block replacement. Wait, this is a sliding block replacement. Oh, and that's it's not even a metronome. It's a sliding block replacement. It's ridiculous. It's not even an actual metronome. And what in the world? Use metronomes for violins or something? Anyways, yeah, okay, so never mind about that. I'm gonna close some stuff. So we're pretty much solved everything. And this is the three-dimensional momentum. Okay, so we're gonna close some stuff. There's the metronomes and people. And fractal moment. Okay, let's take over the game and modern discharges, electricity through gases. Okay, let's play this right here.
All gases, including air, are bad conductors of electricity under room temperature and pressure. But these gases can become conductors at very low pressure and
okay, so gases can conduct at low pressures. Interesting.
High electric potentials, which led to the invention of the device known as the discharge tube. A discharge tube is useful in the study of conduction of electricity through gases. It is interesting that the pressure inside the tube can be varied, and the gas...
Where's an actual charge? I just want to see something. Corona discharge. Okay, see, maybe it's in here. Corona discharge. I can see if this has a video on it. Let's just see something.
Our final topic.
Like I just want to see the actual experiment. Like I don't really care what
so
this
here
guy's...
can actually make. First, it can make a corona. You saw a picture of the corona. But then, if I turn it fast enough, you'll make an arc. Right, so if you get it going really fast, oh, there's one. So you can see the arcs.
Okay, but anyways, that's not what I want. I want to see electricity. This guy's an image there, but doesn't show the actual thing. Like, what it is? Why do they do this? I just want to see an actual discharge. Okay, there it is. Gas discharge. Okay, cathode ray tube.
Evaporates without melting, but most things And I can show you several examples of a plasma. And I've got back here a tube that right now has air in it. And so in order to make a plasma, one of the first things we need to do is to lower the pressure. So I'm going to turn the vacuum pump on and lower the pressure inside this tube. Now, to make a plasma, we need to heat it somehow. We need a source of energy. And I'm going to use electric energy. That's one of the most efficient kinds of energy we know. And so I'm going to put about 500 volts between these electrodes at the two ends of the tube. And when I do that, I hope that we will be able to make a plasma for you. Now, this may take a moment because it is only, there we go, as the pressure drops, we reach a point where the gas becomes electrically conducting. And now I'm going to take a very powerful magnet and bring it up close to the plasma and show you that, in fact, we can affect the plasma with a magnetic field.
Yeah, but notice can you see what's happening here? So notice how there's a big gap here. So this is the positive electrode. This is a positive one that's negative. So in other words, we have a visual demonstration of which one is positive and negative. So this one has the high electrogen. This one has low electrogen. I'm pretty sure that's it. Okay, so this is quite remarkable. Okay, so we have now observed that this guy, I'm trying to tell y'all, this guy is not to be messed with. This is why I cover this guy. This guy's onto something monstrously big, guys. Okay, this is literally we literally solved. Literally solved it. Okay, this is quite ridiculous. Where is the image? Okay, that's I think I posted it. Where'd it go? Okay, it's gone. Okay, this one here. I'm gonna do a reply. This one there, summarize, and the image here. Copy. Yeah, copy image. Okay, this is there it is, guys. We just solved it. So without even looking at it, we know that's positive, that's negative, just because this guy took over the game. Okay. And yeah, so also, yeah, since you have that, Bill, do that as well. Just try to spot which one is positive, negative, and then confirm this. So we just confirm that. Okay, anyways. Okay, let's go on next. Like this stuff here, the way I work is, this is a major finding, or even just observation, even if it's already known. But it's like it isn't like pushed out to everybody. Like this would be a big statement said to everybody, and then also like it should be as big as the paper. Like in other words, talk about this as much, and then also talk about the paper because anyway, that's kind of the way I work. So this is massive. This image right there. Anyways, guys. So moreover, I'm gonna start lowering my desk for the last 20 minutes. Okay. Yeah, I'll lower this a bit more. Okay, so basically, negative charge has electrogen. That's where the vibrating is away from the actual metal. And this one, positive, has deficit, so it's right at the metal. So moreover, in rarefied air, so rarefied, I think that means low pressure air, it is observed that a violet light surrounds the negative electrode, and a deep red light, the positive electrode. Interesting. In rarefied air. Oh, this is just air. Rarefied air. What is it in the world? This is high. Rarefied air. Can anybody explain to me? Like okay, what is rarefied air? And that's just like I think it's just low pressure air. I think we'll ask this right here. Instead of using grok, again, I'll be trying using this as much as I can. Ask Leo, what is rarefied air? Yeah, so instead of using I'll use this open source stuff and put on the blockchain. All the data is there. Again, instead of feeding the billionaires and trillionaires, it just takes a while to load. See, load up. Ask Leo. Oh my goodness, see how long it takes. Okay, it's not there. Okay, it's still not asking. So what is rarefied air? Let's Google it. And we'll have the AI set up there. Refers to air that's lower density and pressure, typically found at high altitudes. Okay, so that's rarefied air. Again, that's what I expected, basically at low pressure. It is observed that a violet light surrounds the negative electrode, So violet is a negative light, and a deep red light, the positive electrode, is I7. A treatise on electricity and theory and practice in 3 volumes, Longman Brown, okay, which reveals the true difference between a positive and negative electricity. So positive and negative electricity, basically the positive and negative charges. Since violet light has a higher frequency than red, this means that the electrogen acting on the rarefied air and causing it to produce violet light is in a state of vibration of a higher frequency than that on the positive electrode, causing the air to emit the deep red light. In other words, the negativity of an electrode is given by the frequency of vibration of its electrogen, and the lower the frequency, the more positive its character is. So basically, higher frequency equals more negative, more electrogen, and yeah, it becomes more negative. Yeah, more negative just means more electrogen that's vibrating, and they're vibrating faster. In other words, the negativity of an electrode. So how negative it is given by the frequency of the vibration. And it's basically higher frequency light. Violet has a higher frequency. In other words, shorter wavelength. It's vibrating faster rate than the red. And that is, so that's a cool part. So in rarefied air, violet light surrounds the negative electrode. Let's see the colors right here. He has. Let's see if there's a color. It should be here. This is something to note as well. So if you can do that experiment, Bill, that'd be pretty cool. Just check the colors of the positive negative electrodes. Okay, that's from this guy here. And this guy's an 1856 book. A helpful way to visualize a surplus of electrogen on the surface. I guess what do you mean by surplus? So I did this demonstration before, but you weren't here, Bill. But I'll do it right now just to show you what I mean by electrogen and why this guy I think is real deal. Okay. Alrighty. Alright, so I'm back. So we got this. I did this last time. So we have paper towel. So I'll make this bigger. I'll have money again soon, and I'll be able to building plasma balls. Epics up. Sounds good. Okay, I'm gonna make this bigger. You guys see my giant head? Okay, so now you see these two papers, and see this right here. So right now they don't stick. They both have deficit of electrogen. There's nothing happening. But if one of them has electrogen, there's one of them. I'll put some water on it. All right, let's dip some water in this. Whoops. How do I put some water on this? Ooh, I'm putting some water on this thingy. Put some water on it. Okay, let's do some wet. Make it wet. Oh, I put way too much water. Okay, I spilled water everywhere. It's all good. All right. So now this one has a bunch of electrogen. This is all wet. And what happens when I put another one that has deficit? They stick. All right. So now they stick. All right. So we have static electricity just with fluid dynamics. All right. All right, epics up. Okay, so anyways, a helpful way to visualize the surplus of electrogen on the surface of metals. So on the surface of metals, is shown in the picture below, taken from a video made in zero gravity. Yes, sir, cohesive force. Yeah, definitely. That's the whole idea, basically saying electricity is just this. So to visualize the surplus of electrogen in this, a helpful way to visualize the surplus of electrogen on the surface of metals is shown in the picture below, taken from a video made in zero gravity in the ISS. The water on the cloth corresponds to the electrogen and the cloth to the metal itself. So if you have metal and then you have the electrogen sticking to it like that. I like this demo. You literally decrease electrical resistance by adding the water. Yeah, definitely. And it just sticks to each other. Yeah, so now you have the cloth is the wire, water is electrogen. So there it is. Chris Hadfield, Canadian Space Agency, ringing. Why is there no link? Yeah, when the electrogen travels along the wire as a diffusion wave, so basically, basically goes from higher pressure to lower pressure. I think that's what it means. Or just goes, higher pressure, lower pressure. When the electrogen travels along the wire as a diffusion wave, it constitutes the direct current. So direct current is just when the electrogen is just going through the wire as a diffusion wave. So you have a high pressure, and it just moves. It just oscillates all the way over to the low setup there. And then the other part is the mainstream is set up because it has minus and negative. It had them flipped over. The positive should be the electrogen. The negative should be the one deficit. So it's like they have it flipped over on purpose, or so. What's going on here? So everything has to be like completely opposite of reality. So when the electrogen travels along the wire as a diffusion wave, it constitutes the direct current. And remember, current goes opposite direction of the it goes towards the positive one. Even though it's the negative side is this one. I think current goes opposite. Yeah, I think it's opposite direction. Oh the current goes opposite direction of I think is it opposite direction of the something like that. Let's see. Current goes opposite. Current is opposite of charge flow or like something like that. I just want to see. Water, not dye water. Interesting. Dye water. Okay, yeah. So why does current flow opposite of the direction of electrons? So yes, current flow is current is a flow of electric charge, while the opposite would be a lack of flow of charge. Okay, what does it mean? Of charge flow. Okay, I hate electron flow. Yeah, so let's see here. So positive electron current. So if you have positive and negative, the current actually conventional current. What is it? Why is that? I don't understand. Okay, direction. It is direction of conventional current goes opposite of electrons flow. Deionized water. Interesting. Okay, let's see what this is. See if this works finally. Okay, there it is. For air high altitudes. Okay, there's the Rafiki AI bot on the Hive blockchain. Okay, so let's go back here. So that's interesting. So current flow. So if this is positive, negative, current would be this would be reverse. Let's try to reverse this. Electronic current holes. Okay, this is positive. Why is it always positive, negative? I just want to go to negative, positive. Okay, there it is. Okay, electron flow. Current is going opposite of electron flow. Electrons go opposite. Oh yeah, so the electrons, would they go opposite? I'm just trying to see what electron surplus. The current is going this way, but the actual thing, doesn't it go opposite? Let's see, negative. Oh no, negative current flow of negative charge. Why would the negative charge go to the negative? Doesn't the negative go to the positive? Like, I don't understand what's going on here. This is the correct one. Negative goes to the positive, okay? But the current's opposites. Yeah, so for some reason, so the negative, this one's actually going to the positive, but the current is on the other side. So it goes from positive to negative, the conventional current. This one's much, I guess this is the correct one. Everything else, I don't understand why they're wild. Okay, I'm just going to copy this. Copy. Yeah, this is an important image to grasp. Room conditioner gives deionizing water. It is like geometry. Just saying that these guys got it wrong. I don't know why they, well, probably on purpose to make things confusing. Okay, okay, and then copy this. So basically, yeah, so that's it. Yeah, so and now you'll understand why current goes that way. It's going to a deficit. So there's a high pressure there. It's going to the negative pressure. So you have so when the electrogen travels along the wires as a diffusion wave, it constitutes the direct current as shown in the figure on the left. Below actually. IV9. I'm gonna write it below. Picture. Oh, but yeah, actually, in the paper it says left. Here I have it below. So I'll do that right here. IV9. IV9. Okay. IV9. Below. All right. Yeah, that's for direct current. Electron goes from negative to polar. Yeah, no, I know that. I'm just saying the conventional current's wrong. They should reverse it. They should make current go the same direction as electrons go. In other words, as the electrogen goes. So they have it wrong. Like I'm saying the conventional setup. They did it because they just assumed what's positive, negative, as opposed to grasping what is actually happening. So that's why it's just counterintuitive. IV9. Okay, so we're back here. So anyways, so electrons go in. If you just look at the surplus, goes to the negative. It goes to the deficit, which is the positive. So again, everything's wrong. This should be positive. This should be negative, and then it goes in direction. Conventional current should be going from left to right, not opposite. Anyways, Okay, this was discussed at length in the previous part 1 and 4 of the series. Sir, the buff comment. Yeah, I know, but sir, listen to what I'm saying. Like, what in the world's going on here? That's for a direct current, the electron goes from yeah, this is direct current. Yeah, it's going yeah, it's not oscillating back and forth. But anyways, I'm trying to say is the direct current mainstream is wrong. They should literally change it so that the convention it goes in the direction of electrons. It is based on the angular velocity. What no really talking about. I think it's just based on convention. It's literally based on convention. Let's see here. It's like angular velocity. What are you guys talking about? It's typical conventional current. A historical definition established before electrons were discovered. Okay, like I don't know what you want. Even the mainstream literally says this setup is because they made a mistake. Anyways, so again, anyways, if you have any useful stuff, let me know. Otherwise, just say yeah, you're right. They're wrong. They even admit they're wrong. Anyways, going back here. In the okay, so there it is. Basically, high electron goes to the deficit, which this should be negative, this should be positive. But again, conventional current for some reason goes from opposite, which is ridiculous. So in the remaining part of the section will be considered examples of electrostatic phenomena in their explanation in terms of molecular vibration. So now we're doing next level setup here, and yeah, we'll see how much we can get in here. Okay, so in the remaining part of the section will be considered examples of electrostatic phenomena and their explanation in terms of, okay, when you study more chemistry, you will see that it is like magnets, their size and shape, and gives them, and makeup gives them a direction so they turn just so it happens it is spin. Yeah, but what are we I'm talking about the current direction. I'm saying the current direction is wrong. Sir, what do you think light and vacuum can't be act as a particle? If yes, then double slit it won't work in vacuum. What? Can't act as part? No, it can. Like it's the interpretation of it being an individual particle is wrong. That's the because look at them on a microscope. Anyways, double slit. You can explain double slit just using normal wave stuff. But the key thing that's going to be here is that the actual light goes into channels. So it's and also double slit on yeah, that's for another day. But you can explain that. What I'm trying to say is you can explain the double slit with just ether, this ether model. Like there's no, you don't need to deal with random particles, like particles based on definition as opposed to anything. Like what is an actual particle? So anyways, so in the remaining part of the section will be considered examples of electrostatic phenomena and their explanation in terms of molecular vibrations. In order to show the excess or deficit of vibrating electrogen on the surface of an object. Okay, so in order to, anyway, okay, now we're going to be dealing with molecular vibrations. So in order to show the excess or deficit of vibrating electrogen on the surface of an object, I will use a representation similar to the electrical density, which is defined as the quantity of electricity per unit area at a point. Okay, angular velocity like the Earth is on an angular velocity is not up and down, left, right. Yeah, but, I know, but what are we talking about? Yeah, you could be right, but what are we talking about? I'm talking about this. I'm not talking about angular velocity. I'm talking about the direction of current. Even Fractalwoman says that she doesn't like how the conventional current got it wrong. Like, ask her directly. Is a conventional current right or wrong? It's wrong. I'm not talking about angular velocity. I'm talking about this direction is wrong. Ask her too. She'll almost certainly say the same because I heard her say it before. So, in the remaining part of the section will be considered examples of electrostatic phenomena and their explanation in terms of molecular vibrations. In order to show the excess or deficit of vibrating electrogen on the surface of an object, I'll use a representation similar to the electrical density, which was defined as the quantity of electricity per unit area at a point on the surface, and called by Poisson thickness of electrical stratum. Okay, in order to show the excess or deficit of vibrating electrogen on the... Okay, so it's basically be using electrical density setup, which was used by this Poisson guy as just how much electricity per unit area, and he called it thickness of electrical stratum. Okay, so examples of such representations are shown below, where it is seen that the distribution of electricity on a conductor depends on its form. Interesting. So distribution on a sphere. Yeah, so yeah, on its form, we'll also have a different electrogen setup here. So distribution on a sphere is just like that. This is electricity and magnetism. Okay, so now if you have the distribution on an ellipsoid, will be bulging out on the center like that. Okay, this guy says, where's the proof of this, sir, that the conventional current is wrong? No, the direction is wrong. Like, it literally says it's based on an error. This was, you can just go ask AI, like, it will tell you right now. A historical division established before electrons were discovered. But both directions represent the same net movement of charge and are mathematically equivalent. Yeah, you just have to put negative on everything. So it's wrong. It's like, it's literally just a mistake. Electric current before electrons. Yeah, I think historical before electrons or something like that. Electric current. Yeah, so what I mean is, its definition was done before electron flow, before they discovered the. So that's why it's not in line with electrons. So they have to. So in other words, it's wrong. it's a mistake. Another thing that's wrong is pi is wrong. Tau day. So pi is wrong. Tau is actually the proper thingy should be tau instead of using pi. So pi should be multiplied by 2. So it should be called tau. It should be 6.218. So in other words, pi is wrong. The conventional current direction is wrong, and that's just basically just Google it. It's like it's all the same thing. So tau day is right, and I did a video on pi being wrong. You can see this. This is a pretty good setup here. So tau is the real thing, and so pi has you also have to add a random thingy. So like the circumference of a circle should be it shouldn't be what's it called, pi r squared. It should be 2 tau 2 tau r. That's for another pi d it should be 2 pi r, not 2 tau d. Anyways, no, tau is where's the tau manifesto? No, circumference of the circumference should be tau, not 2 pi. What is going on here, man? I got peeps message. Anyways, and I made a video on this years ago. Well, I think one of my first conspiracies I ever did was it's not conspiracy. It's just it's wrong. Okay, pi is wrong. Pi is wrong. She also said chemistry wasn't her specialty. We will move on because you and I agree on everything. This I know you will change your position on as like a gyroscope. No, but what are we saying? I'm saying she's literally said no. You could be right about the other stuff, but I'm just saying the mainstream current. They even admit it was wrong there, but you're saying there's some other chemistry stuff. This disproves Ohm's law. No, you have it. The direction of current just changes all the negative and positives. She also said chemistry wasn't. No, but you could be right on that. But I'm just saying the mainstream even admits that they're not the thingy. But you're saying it's better for chemistry. Yeah, but they might not have used it for chemistry. I'm saying so here's pi is wrong. Is from a video I made years ago. So pi is wrong. It should be tau. So a circle has tau radians, not 2 pi radians. It's ridiculous. Anyways, like I literally don't understand this. I made this how many years ago? 14 years ago. January 6th. Holy. Sir, again, please. It disproves Ohm's law. No, again, Shower, you're just wrong. Like it's just a conventional thing. It's not an actual physics is wrong thing. It's the convention is wrong. According to mainstream, but again, with a caveat, Tammy says it's better for chemistry. But again, you have to grasp, like you have to be able to articulate your viewpoint, given that the mainstream says that they're wrong. So you could be like, no, actually, yeah, in terms of chemistry, it might be better. So that's kind of what I'm saying is, yeah. So get on the same page. Like you could be right, and then we could be both be right. That's the thing. So chemistry thing is not what there was defined on. So y is you can go y is current opposite of electron flux, and you'll see it just be a convention. So positive current is wrong. The historical so let's Google where's the thingy. Okay, where's this one here? Where's the link? Khan Academy. I think they mentioned Khan Academy. Okay, so it says right here, so Benjamin Franklin's definition: before electrons were discovered, scientists like Franklin defined current as a flow of positive charge from high to low. He established current from a point of high electric and so on. Yeah, yeah, this is deeper. Anyways, just do that on your own setup there. Yeah, why is current backwards? No, again, that works. That's for alternative current. Their goal is to confuse you, keep you confused so you don't understand if you have to read through the double talk. Yeah. Anyways, Yeah. Anyways, I don't have time for this. Just go figure it out. It's wrong. It's like by mainstream it's wrong, but again with the caveat, the time says it's better for chemistry. Again, you have to be able to like literally grasp what the person is saying. Like like for example, Shao, you're talking about random alternating current galvanized. So those are nothing to do with what I'm saying. So if they're nothing to do with it, please listen carefully or just rephrase your setup. Anyways, guys, just going back here. I'll go back. Okay. Anyways, we're gonna continue on from here. So we're gonna continue on from this. So the current, yeah, because we got the, and this is why I like these live streams where I understand where the audience is, and I are at disagreement with, or just not even disagreement, just at a miscommunication like block. Oh, and that's current direction. Okay, so mainstream says that it was made before electron flow. It's just a current direction. It's not an actual physical thingy. It's just a person saying this is positive, this is negative. That's it. So I'm trying to say is this should be negative, this should be positive. That's all I'm saying. Do Fractal Woman have a YouTube channel? Yes, go to Fractal Woman. She's on the show, and yes, Fractal Woman is on YouTube, and I posted a video too. Fractal Woman, just go here on her channel. Okay, anyways, so that is Fractal Woman. Okay, that's all for today, guys. I'm gonna continue on with this. We'll continue on from this electrogen part, or just right here. Yeah, and then we'll go over through all this, and then he goes through examples on it, how you can do other stuff. And the cool thing I think, which is another eye-opening stuff, is that discharges. Yeah, it goes over a lot of stuff, but the one of the key ones is that that lightning or light flows in a discharge. So basically, light goes into channels like this. It's not an actual wave like just a spherical wave. The spherical wave is the average of all these, but it's actually discharge, and that can also explain some of the Hutchinson effect randomness and / particle like behavior. Because if it goes into channels, that changes the game. All right, anyways, that's all for today, guys. And then, but on average, it's a giant spherical wave, but on individual, it's a lightning strike. Well, I didn't know. Yeah. Anyways, Fractal Woman is top notch. Okay, that's all for today, guys. I'm gonna end the stream, and we'll continue on next time with the electrogen, with the positive charge. Okay, thanks for joining. And have a great day. Okay, let's go send it here. Yeah, there's nobody else in another chat. Okay, that's all for today, guys. I'm ending the stream in 3, 2, 1, and